So here are the notes for 7.2 angles, or sorry, 7.1 angles. This is page 2. So we're going to start by drawing angles in standard position. When an angle is positive, that means we are moving in the counterclockwise direction. We have this arc in here to show us actually which direction that angle is going. Again, this is an acute angle between 0 and 90. We could have drawn one into quadrant 2, made it a little larger. We'll do that here in B where we're looking for a negative angle. So here's again our initial side. It's along the positive x-axis. This one is obtuse, but we've got this arc showing us which direction our angle is going. C, we want a quadrantal angle. And so again, our initial side, and we've got something that ends up on one of the axes. This one is going to go straight up. That is a 90-degree angle. So now we're going to work a little with actual degree measures. If we want a 45-degree angle, again, here is our initial side. 45 is halfway between 0 and 90. Again, we're going to show the direction, positive 45 degrees. B, we have got a negative 200-degree angle. So we know all the way around the circle is 360. Halfway around is going to be 180. We're going in the negative direction. We want it to be a little more than 180, so a little more than halfway around. And so our negative 200-degree angle, roughly like that. We're not looking for exacts. We're going to be okay. So C, a 405-degree angle. So here's the weird thing. This is more than 360, so we know that we've got to go all the way around once. There's 360 plus another 45-degree angle. That gives us our 405. Ooh, I guess I should have started with the initial side. So here we've got 360 plus the additional 45 to give us a 405-degree angle. Okay, notice something. A and C are both 45 degrees above that horizontal positive x-axis. So we notice that they end or terminate in the same place. So we're going to say they end in the same place. Okay, so the terminal sides are in the same place. Angles that have the same initial and terminal sides are called coterminal. Basically, they share the terminal side. The initial side for everybody's in the same place for every angle. And so we're really just concerned about our terminal side, where they're ending up. Okay. A minute there. On 6, we know that an intercepted arc has the same measure as the central angle that cuts off the chunk of the circle. Okay, so a couple of things here. From the center to a point on the circle, that's our radius. And that's the distance from the center. The center is always fixed. So that's the distance from the center to any point on the circle. Okay. We can also, well, let's pick up a different color here so we can distinguish. We can go all the way across. And that's the diameter. Diameter connects 2 points on the circle and goes through the center. It's also 2 times the radius, and that's how we're typically going to use it. Okay. A couple of things we need moving forward. The formula for the circumference of a circle, or circumference, equals pi times the diameter, or 2 times pi times r, which makes sense when our diameter is 2 times r. A unit circle is a circle where the radius is 1. So we've got a radius r equals 1, which means in a unit circle, our radius is 2 times pi times 1, which is 2 times pi. And that's going to be really important as we start talking about angles and moving around a circle.